Thank you for being here with me today. I am Dr. Kane, Aaron Kane's clone. Hope that's okay. Anyway, again, thank you for being here. Today we're talking about the observer effect. Before particles, before atoms, before matter, there were fields. According to quantum field theory, reality is not made of particles, it is made of fields. Invisible, continuous fields that exist everywhere in space-time, even in what we call empty space. Light is not just a particle and not just a wave. In quantum field theory, light is an excitation, a vibration in the electromagnetic field. Think of the ocean. The ocean is the field. A wave crest is what we call a particle. The wave is not separate from the ocean. It is the ocean. When photons pass through two slits without measurement, the electromagnetic field evolves as a probability wave. But when we place a detector, the photon interacts with another field, the measuring apparatus. The system becomes correlated, and what we call collapse occurs. But in quantum field theory, collapse may not be a magical event. It may simply be decoherence. The superposition doesn't vanish. It becomes inaccessible. Decoherence explains why the quantum world appears classical. When a photon interacts with its environment, it becomes entangled with billions of particles. This does not require human consciousness, only interaction. Electrons are excitations in the field. Quarks are excitations in quark fields. Reality is not made of things, it is made of excitations, and these excitations interact. That interaction creates structure. According to general relativity, gravity is curvature of spacetime, but in string theory, particles are tiny vibrating strings in higher dimensional space. Could collapse be the stabilization of a higher dimensional vibration into 3D spacetime? If observation is interaction, and interaction is entanglement, then what role do we play? Are we passive observers, or complex quantum systems interacting with other quantum systems? This continues in part 2. Welcome to part 2. Now we move beyond established physics, into interpretation, into philosophy, into the unknown. Does reality need an observer? The physicist John Wheeler proposed something radical. He suggested the universe is participatory, that observers are necessary to bring definite reality into being. Reality may not be fully defined until interaction occurs. Your brain is made of quantum fields. The photon you observe is a vibration in a quantum field. There is no fundamental dividing line between observer and observed. Both are excitations in the same underlying reality. Mainstream physics does not claim that human consciousness is required for reality to exist, but what may be true is this. Definiteness arises from interaction, not necessarily awareness, but relational exchange. What if the universe at its foundation is pure potential, a vast ocean of quantum fields? Light does not break down when observed, it becomes correlated. Probability becomes relationship. Relationship becomes structure. From a quantum field perspective, there is one electron field, one electromagnetic field. Everything is deeply connected. Physically, we are not separate objects, we are localized patterns in universal fields. Maybe the universe does not need us to exist, but maybe existence is interaction. And participation is what gives reality form. We are not outside observers. We are part of the equation, not watching the universe, but happening as it.